Hello YouTubers, welcome to my shop. Let's talk crankshafts. Alright, so I dabbled in making a few crankshafts here and there. A little disclaimer, I am not a machinist and I never claim to be a machinist. I have been machining for about 5 years now. I'm a carpenter by trade. So these cranks, I use the same method on all of them. Here's my double acting steam engine, and I made a crank out of a 2.5 inch bolt. It was a 2.5 inch diameter bolt and soft steel. It was a pain in the buttski. I hate machining steel. This is going to be a Crossplane 4-cylinder. So each throw is 90 degrees apart. So I really only found one decent method of making cranks for the home machinist. And this method requires a 4-jaw chuck and a tailstock. This is a 2 3/16 diameter dowel, and I've got all the layout lines marked out on it. That's really the key to that. My other trick is I'm going to do a bolt circle. In this case I have 2 bolt circles because I can't decide if I want an 1 3/8 stroke or an 1.5 stroke. So I did 2 bolt circles and I'm still up in the air about which one I want to do. The crosshair lines get transferred all the way to the other end of this dowel, and we do the same thing on the other end. And this I did all on the lathe, and I just used my tool to do the crosshairs, and then I just, with this locked in place, I drug my tool all the way the other side. Of course, the chuck jaws are holding it, so that last little bit of line had to be transferred. I had to flip the part and transfer those lines to the other end and do the exact same thing. Get all your layouts on here first, folks. That's really important. And it took me a while to do this. This is not a quick process. The better your layout lines are, the more accurate everything else is going to be. Because these layout lines, these are God. Okay, once you make that line, that's it. From here on out, the crank is going to be built around these lines. This was my original attempt at making this crankshaft. I decided to try a new method, and it was to make all these pieces separate and then weld them together and then finish it up on the lathe, make it true. Well, for one thing, it's ugly as hell. I don't like that. Even if I was to sit there with a grinder and meticulously try to make it pretty, I just don't like the way it looks. But the real problem is here, I tried to cut one of the throws, and it's really hard to get a consistent cut because we have a hard weld, hard steel, and then it gets soft in the middle and then hard again. So I didn't really like that method completely. This engine is going to have an oil pump, so I made an oil journal in this, and then I was able to use steel brake line as the centering pins, and I put it in the holes and clamped all this together. I clamped this in a what do you want to call it, angle iron, to keep it as straight as possible, and did all these welds. It took a lot of time. It's nice because there's all this material already gone. I don't have to deal with removing all this. But the final product is, I don't know. If I go through all the trouble of making this engine, and I do want it to be a nice engine, I really want that crank to look nice. So that's why I went back to the idea of removing the material from a solid chunk. So first thing I like to do is face both ends of this dowel. I'm not even worried about the diameter yet. That's like the last thing I do is the final diameter. What I'm focusing on is the throws and how am I going to remove all this material. Here's the first time I tried this. Now everything was going great, right? I had my layout lines. Excuse the rust, everything rusts in North Carolina. But anyhow, the best way to remove material is with a drill. And so I started doing that on the drill press, and I was going to hog this out, then take my grinder and grind out as much as I can down to something similar to round. And then I can do the rest on the lathe, right? Well, I fell asleep at the wheel, and this hole was supposed to be over here. This hole is fine, but these were supposed to be opposite of each other. And so I screwed that part up and I cried, and then I had to do it over again. So here I am on the second try, and I thought I'd make a video about this because I don't see very many videos at all regarding the home machinist making a crankshaft. I don't know if they do this in high school anymore, but when I was in high school, we learned how to draw with a pencil and eraser. I like to draw my stuff out before I start cutting. There's a lot of stuff that needs to be figured out, but mainly scale is one thing that I'm always concerned with, and sometimes certain parts might interrupt each other or be in each other's way. If you don't have any graph paper, I highly suggest you get some. It makes it so much easier to draw stuff out. This paper is dotted, so instead of having lines going through everything you draw, they just put little dots. And it's really handy for doing a relatively quick drawing when you're trying to figure stuff out. This is my head. I'm trying to work out where the ports are going to go, how the valves are going to be in there next to the spark plug. And so all this stuff can be drawn to scale, and it really helps visualize and see what's actually going to work and what isn't going to work. The trick is to try to remember every single little detail. Here's where I'm trying to figure out the underside of the head, the valves, and the spark plug. And so I drew different size valves and trying to figure out how I'm going to cram everything into a small 1-inch diameter space. That's the diameter of the piston. Actually, it's going to be more like 1 1/8, and I'd like to push 1 3/16. Here's another good example of a drawing helping me see what isn't going to work. So this is the top of the head. We're looking down on the head. There's my rocker arms. And in this visualization, I was able to see that the spark plug is not going to be able to go through the top. So at this moment, I still don't know where the spark plug is going to go. It could go through the top if I move my rockers apart. That's an option, but then I'll have to either angle the rockers to the valve or put an offset on the rocker, like a little L that'll come over and hit the valve. Anyhow, that's something that the drawings really helped me to see, though. I highly suggest learning how to draw your parts first. This crank is coming along. Right here, it's all in the layout. And so when I started this, before I cut anything, I had this in the steady rest. I face this off and I get a perpendicular cross, and I took great care in making sure that cross was perpendicular. And we do a bolt circle, and that's where our holes are going to go for the throws. Now in this case, I have 2 bolt circles because I couldn't decide if I was going to do an inch and a quarter stroke or an inch and a half stroke. Well, it turns out in the end, of course, after I made my marks, I decided to go with inch and 3/8 stroke, which was right in the middle. So I had to do these marks with my compass, my divider, and then I drilled the holes last. And I did that with my lathe pre-drill, but I did it on my drill press. Now setting this up in my 4-jaw chuck, it took me a couple hours, but I have 2 indicators. So I had an indicator on top and an indicator 90 degrees apart on the side. And they were mounted to my apron, and I was able to roll them back and carefully, I'd have to hold the indicators so it wouldn't drop down. So once I had all my layout marks on here, I was able to take this over to the drill press, and the way I did it is I drilled down here, and then I removed that wedge, and then I came in this way and drilled those out and cut them out with a grinder. So you can see I got a good portion of that material out of there. I got something relatively round as a rock, that I can actually machine. And then this is what it turns into right here. I've got oil on those throws. That's why it looks funky on camera, but shit likes to rust overnight here in North Carolina, so I had to get some oil on that right away. But they are polished to, let's see, I went with 1200 grit paper, and then I buffed it with a leather strap, and they are really shiny. Now, I don't want to machine these guys because they're cantilevered so far past the chuck. There's a good chance that this thing will twist. Now I got to flip this part over and indicate it both sideways and up and down and get it perfectly straight. And we get to do 2 more of these. Anyways, I think you kids get the point, and you can see what's going on here. Like I said, this is the whole key right here, is this layout on the end. And then you can put it in your tailstock, and we get our lope. I just did this throw right here, so you can see that's what's going on. So here I have 2 flywheels, and I'm thinking about using a bicycle sprocket system for the timing chain. I got this. This is a good score I got from the Metal Recycle. It's some sort of flywheel. It still had the packing paper on it, so it's brand new, even though it doesn't look brand new. And I'll probably, cut the width down. And the other flywheel, I'm going to try to turn out of this. Although weights like this can be hit or miss. Some of them are extremely hard and ridiculous, and you might as well throw it in the trash because you could never machine it. Some of these are machinable. So, like I said, it's hit or miss. It just depends on how fast it cooled at the factory when it came out of the thing. I've got a chunk of red brass I'm going to use for the bearings. It's a nice piece. That diameter is about 3/4 inches, I think, and it's going to be 1 inch. So yeah, this will be a nice bearing for that crank. And of course I'll put it in a pillow block. I'm going to pour the pillow block with aluminum and have it machine it, of course, to fit this bearing. Alright, YouTubers, I'm finally getting somewhere with this. I've got all 4 throws cut and polished. And I just set this up to get ready to machine the ends. I have a bearing to make here. This will be a main bearing, 1 inch by 1 inch. And I have another bearing right here, 1 inch by 1 inch. Those will get cut and polished, nice and pretty, and then I'll do a rough surface on this part of the shaft right here where the flywheel is going to go. It's going to have a flywheel at both ends, kind of like the Macbeth engine. And one of the flywheels will have a timing gear or a timing chain, timing belt. Not really sure what I'm doing yet. Well, I hope this will help somebody out. Like I said, I know when I was learning how to make crankshafts, I looked all over YouTube for methods for making crankshafts, and I couldn't find much of anything. Obviously, there's videos of guys making really small crankshafts, like for little tiny models, but I'm trying to make one that's a little more bigger and something that'll actually perform some work. I don't want this to be a toy. I mean, it is a toy, but I do want it to perform work. So anywho, hope you folks have a great day. Thanks for watching.